Hey everyone, so in this video we're going to show you how to add algebraic expressions. Now if you're not familiar with what an algebraic expression is, then please go check out one of our other videos where we talk about the basics of algebraic expressions, because to add algebraic expressions you need to know what the terms of an algebraic expression are, you need to know what like and unlike terms are, and you need to know what the coefficient of a term is. So these are three things you will need to know, and you might be able to follow as I walk through these additions. But in case you have any doubts, just go check out that other video on the basics of algebraic expressions, and any doubts should be cleared with that. So let's jump straight into it. These are the two algebraic expressions or polynomials that we're trying to add. In this case, this is actually a monomial, right? It's just one term minus 5x, and here second polynomial is 3x squared plus 4x plus 3, which is a trinomial, right? It's got three terms. So what do you do? Well, let's just jump straight into the approach. It's very simple. So P1 is for polynomial 1, P2 is polynomial 2. You just arrange the polynomials in a way that their like terms, right, coincide or align together. And what do you mean by like terms? The terms, so in this case minus 5x and 4x are like terms, because if you take out the coefficient, the variable part of that term is the same. So those are like terms, right? A term is basically, in this expression, each collection of constants and variables that are separated by plus or minus signs are terms. So this is one term, this is a second term, this is a third term. In this case, it's just one term. So those are terms, and the terms like terms are terms that basically have the same variable, or variable combination. So anything with x square would have been a like term, but there's no x square here. It's just x. So minus 5x and 4x are like terms, right? So you arrange it like that. So let's start with the first one. The first, polynomial or monomial here is minus 5x. So I've just arranged that. And now this is the first thing we're adding in this case. So, I'm just adding a plus sign here to indicate that all the terms here are meant to be added, right? And you will understand this as we do more examples, why I'm putting these signs, because it just avoids errors when you do these polynomial additions or subtractions. Now let's arrange the second one. So we want to make sure the like terms align, right? And I like to write this from the right side of the screen, that is to the left, right? That's how I'd recommend. You just stick to a system, so it makes it a lot easier. And I like to write it with the constant on the right side. So 3 will come there. And there is no like term here, so I'm just leaving it. I'm just putting it separate away from this 5x. The 4x has to come right under the 5x, right? So because these are like terms, so they align. And then 3x square is a separate term and it shows up separately. And now what do? You've aligned these, you just add them up, right? You just add up the like terms coefficients. So these are the coefficients. For x, the coefficient is minus 5, and here it's 4. And for x square, the coefficient of 3 is 3. For a constant, the coefficient is just the constant value, right? So it's just 3 there. So you just add up the like terms. So what would you do? So the sign here, because it's addition, is plus, and then you start adding. So 3 plus 0, so 3, because there's no term there. Minus 5 plus 4, because it's addition, right? So minus 5 plus 4 is minus 1, so it becomes minus 1x. There's no term here, so it's 0. 3 plus 0, 3. So if there's no term, it's 0, and you add it up. So the sum of these two is basically 3x square minus x or minus 1x plus 3. Simple. So that's how you add polynomials, right? And this is a plus, right? Just remember that. So you've got the sum of the two polynomials very simply. Okay, let's do another example, and this hopefully becomes even more clear, right? But basically you make sure that you align the terms according to the like terms. You add up the coefficients of the like terms, and what you get is the sum. So we've got two trinomials again, and we're going to try and add them up. So again, same one, polynomial 1, polynomial 2. Let's put the first one. So 6x, xy, and minus 3xy square, right? Now what you would notice here, right, immediately is that actually I've written this here as xy minus 3xy square plus 6x. But when I've arranged it in a slightly different order, right? I've arranged it as 6x, xy, and xy square. So we'll just come to that. let's align the second polynomial under that. So the constant term 9 will come here, 2x will be under 6x. There's no x squared term, so we'll put 3x squared in this gap. And again, we are adding them, so it's plus on both, right? Okay. Again, this sign concept will become very clear when you have when you have subtraction, or when you're adding, more than 2. So 3, 4 polynomials together. Okay. So now let's kind of look at how and why we've arranged it like this. So generally when you write a polynomial, and so this one that I've written here, I've deliberately written it like this to show you the difference, right? But when you write a polynomial and when you arrange them, one thing you need to do is you need to make sure that you arrange it such, that it's ordered starting with a constant on the right, and then you take the powers of this variable term, right? So, and you order it, in increasing order towards the left direction. So what do I mean by that? Okay, so 9 is a constant term, so there's no variable term, so the sum of the powers of the exponent is 0. Now 6x and 2x, so x is 1, right? It's x to the power of 1, right? And so the sum of the exponents is 1. Similarly, if there's just a y and there's no y term here, then it's y to the power of 1. So if you have 5y, for example, right? This is an example. Then that, the sum of the exponents is 1. Then you have xy, and you have an xy here. So it's x to the power of 1, y to the power of 1. So the sum of the exponents is 1 plus 1, 2. You have x square, which you have here. So square, and there's no y term, so it's 2, right? Similarly, if it was y square, it would be 2. Now what if it's xy square? You see that here. So x to the power of 1, y to the power of 2. And so what you have is 1 plus 2 is 3. X square y, same thing, right? 2 plus 1 is 3. X cube, there's no y term, so it's just 3. And if it's x square y square, for example, it would be 2 plus 2 is 4. And you can keep going like this. So you can see that by adding up the sum of the powers of the xy term, you get these numbers. And when you arrange the terms, you ensure that the constant, which is the lowest number, 0 for here, is to the right. Then any terms with 1 come next. So x, if there was a y, it would come here. And it doesn't matter whether you write x first or y first, but those would come. Then you have xy, which is a 2 term. And you have x square, so you add that, and so on. So you arrange in that order where you have the constant term to the right of the screen or right of the paper, and then as you move towards the left, you move in the direction of increasing number of the sum of the exponents. Okay, so let's just now add this. We have arranged it, right? And so what you get is, adding this, you get 9, 6 plus 2, 8, xy, and there's no term here, so it's just xy, minus 3x square, no term there, so minus 3x square, and minus 3xy square, again no term in polynomial 2, so got minus 3x square. So the sum of these two polynomials is minus 3xy square minus 3x square plus xy plus 8x plus 9. What's interesting here is you started with two trinomials, but because the variable terms are actually quite different, you ended up with a polynomial that actually has 5 terms, right? Because the xy square and the xy have come in from there, the x square and the constant have come in from there, and the x term is there in both, so they have been that's been added up. So hopefully that makes it very clear how to add. Let's do another case, but in this case we are going to subtract the two polynomials, right? So you're going to subtract this and this, right? You're going to subtract this from this, basically. So polynomial 1 and 2, write the first one, so constant term, then x, then y square, and then xy square, right? The reason I'm giving this to you in jumbled in not ordered form is to kind of drill it into your head that this is how you arrange it, right? Now when you write a polynomial, you ideally write it in that format as well. It makes it a lot easier for you to understand things like the degree of a polynomial and so on, which we'll cover in different lecture. So now we arrange this term, so the 9 comes under that, the 2x will come here, there's no y square, there's an x square, so you can either put it here, you can put it here, it doesn't matter, same sum of exponents, and then xy square will come under that, right? But now we are subtracting that term, so the sign has become minus. So the first term is minus 9 minus plus 9, which is minus 9. So minus 9 minus 9 minus 18. What about this one? So it's x, so the coefficient is 1 minus minus 2. So 1 plus 2 is 3. In this case it's 0, so it should be just y square and it's a plus. In this case though, it's 0 minus x square, so it's minus x square. And now you have xy square here and you have xy square here, so that becomes 0. So what you end up with when you subtract, this from this, you end up with minus x square plus y square plus 3x minus 18, right? So you see the x y square term has gone. So hopefully that has become clear, and that's a very easy way to do it. So what you can do is take a piece of paper and just simply arrange the polynomials in a way that ensures that the power terms align, the variable terms, the like terms align, and then accordingly add them up. But now there's a slightly different, what I think is a slightly simpler way to do this if you're getting confused with this, right? And that's using a table. So what do? You draw a table and you fill in on top, you have columns here, and each column you add the unique or individual variable terms. So you have a constant which is there for most equations. Then in this, you look at these, there's x, there's xy, right? There's xy square. So I've just filled that in. Then what you do, I've arranged the polynomials. So it's the first one here and the second one here, and I'm adding these two in this case. So I fill up the terms according to what's available. So I'm filling this one first, and so the constant here is 0 because there's no constant term here, right? So it's 0. There's an x term, 6x, right? So 6 will come there. Xy is there, it's 1, so xy. And then xy square is minus 3, so it's got minus 3, right? And how do you know this is a polynomial? So minus 3 xy square plus xy plus 6x, right? That's how you would rewrite the polynomial. What about this term, right? So I've just done it again quickly. The constant term is there, and so the constant term is 1. There's an x term, so it's minus 1. There's no xy term, so 0. And then there's the xy square term, which is 2, right? I've added the signs to the left, right? I'm adding these two, and so I'm just putting the signs there. And now what you can do is just add the columns. So 0 plus 1, 1, 6 minus 1 is 5, 1 and 0 is 1, and minus 3 plus 2 is minus 1. Now how do you get the sum? So you've already got the sum of the coefficients. So the actual polynomial, which is the sum of these two, is minus 1 xy square plus 1 xy plus 5x plus 1. Simple, right? So I think that is something I find very easy to do, and the reason I'm doing this is now let's try something slightly more complicated where you've got 3 polynomials, right? And what I want to do is, this is the first one, I'm subtracting this from that and then I'm adding this to that. So you can see that with the sign. The first one, I'm subtracting this from this, but then I'm adding this. So obviously the simple way to do it, the first approach, is just aligning the terms. But I think in this case, using a table makes it extremely easy, right? It's just super easy to do it. So in this case, there's no constant term, so that will be 0. There's no x term, so that's 0. The xy term is not there, so that's 0. The x square term is there, so that will be 5, and the xy square term is there, so it will be 1. That makes sense, right? I'm just left these empty. You can just write 0 there if that makes it easier for you. Now what about this term? So 9 will be the constant term, 2 is the x term, xy is not there, x square is minus 3, xy square is 0, not there, right? And I've left the minus sign here, so that will help me remember that I'm subtracting these coefficients. And then the third equation, constant term is 5, the x term is minus 6, the xy term is minus 3, the other two are 0. Now what do? You already know the answer to that. You just add up the columns. In this case, you just have to remember that you have to subtract this middle column, right? So it's minus 9 plus 5 The next one is minus 2 minus 6, because there's a subtraction here, right? Just in this case it's just minus 3 because all the other columns are 0, all the other rows are 0, sorry. In this case it's 5 minus minus 3, which means it's 5, effectively 5 plus 3, and in this case it's just 1. And that's it, right? Now just evaluate these. So you've gone to minus 4, minus 8, minus 3, 8 and 1, and what you've ended up with is the expression xy square plus 8x square minus 3xy minus 8x minus 4. So now you've seen how you can add or subtract more than 2 polynomials. Hopefully that's very easy. And so now what you can do is kind of test if you've really understood this concept, and to do that just go to teachyaar.com, and we have uploaded this free quick test there. And so what you can do is just take this quick test. You can scan the QR code on your mobile device or go to this link, and we have dropped this link in the comment section and the description section. So just go, click on the link or scan the QR code and take the free test, and just see if you understand or you have any doubts in this. You can go back to the video and kind of clear any doubts you have. And when you submit the test, when you hit the submit button after taking the test, again it will show you the solution, it will show you some feedback which will help you understand, or make sure you've understood the concept. And so please subscribe to the TeachYaar YouTube channel, and if you like this video, give us a like, and if you know somebody who will find this useful, feel free to share this with them.